All right, so this is a quick demo of how Azure Site Recovery would be used to fail over a VM that was constantly replicating up to the Azure platform. It's going to be a super quick demo. No setup really is covered. Just going to kind of show you when it is going, how it works. We've just got a really basic environment. There's a single server domain controller running on-prem right now that we're going to fail over, and then we're going to leverage a dynamic routing protocol so that clients automatically are connecting to that resource even after it's been moved. So we'll kind of add the networking component too. Just to get our bearings here, we've got a resource group here, the DR resource group, or DRRG, and you can see in here it's got a storage account. We've got a VNet. This is the destination VNet that our domain controller, when it's failed over, will land on. We just go in there and look at the properties. Just take note of the subnet here. This is the 10.200.201.0/24 subnet. So this is the subnet that the on-premise version of this VM in the VMware environment is on. And the idea is that we'll maintain that after failover. Additionally, here you've got a DR Vault. This is related to the setup of site recovery, and you've got the disk that's being replicated from our on-site VM. I'm not going to go into this config too much, but I'm going to just touch on the routing infrastructure. I've got a Sonic wall here deployed on the Azure platform. I just picked it from the marketplace. You could spin up other appliances, FortiGate, Cisco. There's other flavors of routing devices out there. And right now, if you look at the routing table of the Sonic wall, remember that VNet subnet, that 10.200.201.0 subnet. Right now, this Sonic wall thinks that network is reachable over this, what's called a tunnel interface. This is related to a VPN that's down to the on-prem environment. So right now, you can see that the Sonic wall doesn't realize that network for that VM that we're going to fail over is local. And again, that's related to the dynamic routing protocol. So the idea is that on the on-prem device, which is pfSense box, another VM, we're going to take LAN 3, which is the interface that serves up that 10.200.201 network. We're just going to take this down when we fail it over, and we'll create a static route over here. This will drop away because that network will no longer be part of the OSPF dynamic routing environment. And we're going to create a static route in here, and static routes by default on this particular Sonic wall are injected into the OSPF database just using this. It was just easier to check this box rather than getting into the CLI. You can redistribute static routes individually, but this checkbox just does them all. All right, let's get started. It'll be good to note that all the clients are on this LAN network, 10.200.201. In my case, the client is just a little Windows 10 box, and the IP address of the server is 10.200.201.10. So you can see we can ping that right now. We're getting 1 millisecond latency. That's because it's all on-prem. This client is simply going out of this LAN interface into this LAN 3 interface, never traversing the internet. And here is our domain controller VM. You can see it's just a flat domain. Haven't really done anything to this. Hardly any data here aside from the OS install and the Active Directory deployment. Nothing special here. Oop. You can see 10.200.201.10. Cool. So back over to site recovery. If we go into this DR Vault, which is a vault that we had to deploy in order to set up site recovery, this has a lot of the site recovery items. And again, I won't really get into the nitty gritty of how it's configured. I really just kind of want to show it off and just do a failover and talk about it some. But if you look over at replicated items, you can see that AZ SVR test 1. This is that domain controller that's on premise. is the only one being replicated. We can come in here and we can see that it's protected and healthy. We can see a test has never been performed. So we can do a test failover or a for real failover. And then we can see kind of a diagram of the replication setup. So in order to get replication set up, I did have to deploy an appliance that was provided by Microsoft. That appliance is running on-prem. Um, it had 16 gigs worth of memory required, which was kind of steep for my lab environment, but I went ahead and did it. That's this AZDR VM, and you boot up into like a Windows Server 2016 type experience. It's an OVF template that you deploy into your VMware environment. It goes through this little checkbox where you add your vCenter server to inventory. It does a discovery of your VMs, and that's kind of how you pick VMs for replication. So this diagram is just saying that, hey, this on-premise replications appliance provided by Microsoft does have connectivity to vCenter, and it has connectivity to the VM that it's responsible for replicating. And then over here on the Azure side, it is saying, which storage account it's using for the cache storage, the replicated disk, and just the fact that it's connected to site recovery, I guess. I'm sure there's probably a better way to describe that, but I'm pretty new to this myself. So let's do this. Let's just do a test failover, which will not really touch the on-premise environment at all. We can just shut that off. If I do a full failover, right now I don't have failback configured, so I kind of have to start over from scratch. So really the only difference between a test failover and failover is when you go to do a failover, it like offers to shut down your on-premise VM for you, and I think will allow you to convert or instantiate the replicated VM as a permanent instance versus the test. It kind of assumes that you're going to stop the test at some point and not remain in that state forever. But for the purposes of our demo, just to bring it up and watch it come up and work, I think test failover will work. So let's go ahead and do that. So the first thing I'm going to do is I'm just going to shut down the on-premise VM. So this is the domain controller. We'll do a shutdown, and instead of restarting it, we'll just hard shut it down and force. And just to kind of demo the connectivity, we'll do a -T. This is our client VM that's on the other on-premise network, the 10.200.200 network, not the 201 network. And you can see right now it can contact the on-premise domain controller. So we're going to shut it down, and we're going to watch that ping stop. Here we go. Probably helps if you type it correctly. There we go. Now we're shutting it down, and when it goes down completely, we'll see this stop. There we go. So now we're timing out. Oh no, we've had a failure. Let's go fail it over. I'm going to do the test failover in the Azure console. Oh boy. Welcome to the cloud. All right, so here we've got some choices. Last processed low recovery time objective. Looks like it was up to date as of 2/12. You can see it's 2/19 right now. Or you can do latest or latest app consistent. I imagine that app consistent means that it reaches into the OS and actually, for like a SQL database or Active Directory, for example, it would actually support recovery of an Active Directory server or a SQL server and bring it up in a functional state, taking into account, in SQL's case, the log and database consistency point. In this case, we're not really worried about it, but if you do custom, it's interesting how many options you've got, all the way up to 2/12, and again, it's 2/20 right now, so it's just interesting to see what the options are. I'm going to go ahead and pick 2/12. And a destination network, LAN 3 was that network that I set up for DR purposes, that 10.200.201.0/24. I'm going to hit OK. And that process is starting. Here we go, starting the test failover. So while that's running, I'm going to go deal with networking. And in order to deal with networking, I'm going to go on the on-premise firewall. I'm going to jump into the OSPF daemon here, go into interface settings, and I'm just going to delete this opt2 interface. This is the interface that goes into that LAN 3, that network for the on-premise domain controller. If we go edit, you can see it says LAN 3. I think the default name was opt2. I'm just going to delete this. This means that we'll no longer be injecting that on-premise network into OSPF. So it's gone. Go over to LAN 3, and I'm just going to shut this interface down so that it's no longer even in the local routing table. Go ahead and hit save and apply. Oops. Okay, yep, it's disabled. So go over to diagnostics and routes, and we can see now there is no 10.200.201. We've got the 10.200.200 route, which is to my client VM, which is still timing out, right? But we don't have the 201 route anymore. So I'm going to jump over to the Sonic wall. I'm going to go over to route policies. I'm going to go ahead. You'll notice that first off, the 10.200.201 route is gone. Go ahead and hit add. For a route, the destination route, I've already got these address objects created here. Here's my 200.201 route. The X0 interface, it's going to use the internal interface to route to this thing. And then the gateway, this is the internal gateway for the VNet that's able to reach other VNets. And there was some background config between the VNets that I had to do that just aren't in this video. I'll go ahead and give it a default metric. Most of these others are 20. 110 is your metric for OSPF, but it doesn't really matter for this case. And I'll just call it DR route. Go ahead and hit OK. And great. So now we've got our DR route going to the 10.200.201 network, and it's telling any request for that network to go to this internal gateway. This is a VNet gateway device that is handled by Azure. So we're going to hit that internal routing device in order to get to other VNets. We go back over to routing for our pfSense box and hit refresh. And hey, look at that. We've got a 10.200.201 route now. And you can see it's going over IPsec. And then there's the, this is what they call this is like a /30 point-to-point network. I didn't really explain that too much, but if you look at the VPN configuration of the Sonic wall, for example, you'll notice that there are no hard-coded networks. It's just general, proposal, and advanced. And what it does is it creates an interface. If we go over to network and interfaces, and you can see we've got this Azure X1 VPN interface. And it talks to the on-premise environment using this little /30 network. So the on-premise network, the pfSense, has something very similar. It's 192.168.100.1/30, and this is 192.168.100-2/30. So this is a little point-to-point /30 network to allow the two devices to bring up an OSPF adjacency and exchange routes so that you don't have to hard code routes into the VPN. Okay, so now that we've dealt with networking, let's go check on our restore process or our test. So let's go see what happened within our DR resource group. Hit refresh here. Look at all this stuff that popped in. So we have a new disk. We still have the replicated disk that was there before, but we've got a new disk. We've got a network interface, and we've got a VM. So tied to the VM is this network interface and this physical disk. Before I do anything, I'm going to go into this network interface. And Azure VNets and networking is kind of strange. You don't really go into the OS and set static IP addresses. You've got to do everything from here. So I have to go into IP config. And you remember the IP address of our domain controller was 10.200.201.10, right? And so when it brings up this VM, it's going to be using DHCP, and it doesn't know that I want that static address. I'm not sure why site recovery is not smart enough to look at the source VM and say, hey, it's got, you know, a 10.200.201.10 address. Maybe we should use the same, but whatever. So I've actually got to come into the network interface, which is tied to that VM, and I've got to say, I want you to be a static interface, a static IP. So I'm going to click into that, and I'm going to say static, and I'm going to say 10.200.201.10, and I'm going to hit save, and it gives me a warning saying it may have to bounce the VM to do that, which is fine for this test. So now we've dealt with routing, we've dealt with IP addressing, and the VM should be rebooting in the DR resource group in Azure. And we'll go look at that here in a minute, as soon as we're done waiting for the cloud. And I can't even click away. Look at that. It's doing something in the background. Even though the Azure task isn't completed yet, you can see that our on-premise client all of a sudden started getting replies at 10.200.201.10. But look at the latency now. We're at 24, 23 milliseconds, whereas when it was on-prem, it was 1. So that's already a good sign. That means that our networking setup is solid. The route moved just like we expected. And again, for one site, that's not really a big deal. But let's say you had 30. That's all you would have to do. All 30 locations would have gotten that OSPF route and gone up to Azure for that data instead of this on-premise environment. This is just a really small isolated test just to kind of demo the power. Anyways, this test's finished. I'm going to go back to the DR resource group. Here's our VM, and nothing really huge to see here except the private IP address is now 10. You can see which VNet that it's tied to. You can see what the related disk was down here. Yeah. Anyway, we go back to our on-premise VM. Let's just RDP to it. 10.200.201.10. Hey, check that out. It's up. Not exactly as snappy as my on-prem environment, but I think when I was setting up the replication, out of the 3 hard disk choices, I think I chose standard SSD. Here's our little, hey, we didn't shut down properly warning. This is due to the replication. Just put something in there and get it closed. So let's go look at the networking setup. So before it was hard-coded with a static address, and now you'll notice that as part of the replication process, Microsoft reached in and changed this to DHCP for us. We didn't have to do that. Again, the networking config is all handled from the Azure console. As far as DNS goes, you might be thinking, how did you set DNS? Because in the case of a domain controller, it should be using itself for DNS, right? That's all done in the VNet. We do an IP config all. You can see that DNS is 10.200.201.10. So it is itself. Interesting enough, the DHCP server, this 168 address, I just noticed that. I'll have to look into that. That's some Azure resource that's serving up DHCP in their environment, it appears. Anyway, so let me show you the VNet and how I set DNS. So we go back to the resource group. Here's our destination failover virtual network. And then it's pretty basic. You come into DNS servers, and instead of taking their default, which wouldn't have worked in our case, I said custom, and I went ahead and hard-coded the domain controller. So you'd set up other VNets, for other workloads that all needed to use this internal domain controller. You'd do something similar, and then take care of routing, which they call peering, if they're not within if those workloads are not within the same VNet. So what else can we do in here that's interesting? Let's do a speed test. I haven't done that yet in Azure. What do you guys like? Speedtest.net? Let's do that. Go ahead and bring up the new edge. Take it to the edge of your patience. .net? Yeah, here we go. That's decent. And I have to wonder if this is somehow limited by the SonicWall's deep packet inspection engine. You'll notice the IP address that I have, this 13.64.198.51, it is natting through that SonicWall. It's kind of bogus here because, again, all your Azure VMs have to be DHCP. But here's the IP here. I did go ahead and get a static IP and assigned it to this SonicWall. But if we go down to security services, this SonicWall is kind of like a baby SonicWall. I just got it with the free subscription. It was the minimal amount of cores. I can only deploy so much for testing. So I wanted to make it small, and you can see maximum security recommended. I'm going to go to optimized and just see if that makes any difference with a speed test here. Yeah, a little bit. Well, I don't know. I guess I didn't pay good enough attention to what the results were the last time around. Seems similar. Let's throw caution to the wind and get really crazy on, hey, the services aren't even on. So that's line speed. So it's not even doing DPI. By default, you have to turn all that on. So yeah, that is as fast as the VM goes in Azure, which isn't bad. All right, well, there's our failover test. It's pretty easy to back out of it if it's a test only. I'd like to make one more video showing failover and failback, but there's more setup tied to that. To end the test, you come here in your vault, go to site recovery, replicated items, open up your VM, and you clean up the failover test. And this basically just powers off the VM, removes it from inventory, and just goes back to its replication status, or standard replication. So clean up. Here gives you the opportunity to put in test was successful. If you have a requirement to test DR every so often, you can put in your own notes and say it was completed, delete test failover virtual machines, and hit OK. And you can see that the portal, it's busy doing that. We can come back in here and deal with routing again. We'll go ahead and delete this static route so it's no longer advertising that network. And we'll come back over to our on-premise environment. We'll turn that network back on, save, apply. Go down to OSPF and start advertising it again. Save. Oop, not the WAN. We don't want that. Try again. Great. So now the on-premise environment is back up. I'm on another screen now. You can't see. I'm just powering on the on-premise instance of this VM. Go back over to our client. You can see that the pings stopped working. And as soon as the on-premise instance fully boots, that should start working again. And that would conclude our failover test. And look at that. Now we're back to 1 millisecond delay because we're on-prem again. All right, guys. Thanks. Hopefully that was informative.